Okay, so when we talk about immunology, chapter 4 of Absite review, um, you have to just give a general overview on it, right? And I think there's a lot of numbers, there's a lot of confusion to it, but just like keep it as simple as you can. So T cells come from the thymus. So T for T, and they're responsible for cell-mediated immunity, as opposed to what? As opposed to humoral immunity. Humoral is antibodies. Cell-mediated is not antibodies. It's the cell itself attacking the pathogen, right? So you have helper T cells and you have cytotoxic T cells. Helper T cells are CD4, okay? And CD4 release interleukin 2 and release interleukin 4 and release interferon gamma, and they're involved in the delayed type hypersensitivity, which is type 4. We'll talk about it in a second. Okay. So for now, the way I remember why, like what, so this is 2, 4, and interferon gamma, right? So 2, 4, CD4 sends 2 to grow 8, right? So 4 times 2 equals 8. So 4 gives off interleukin 2 to grow 8. What's 8? 8 is CD8, which is a cytotoxic T cell, right? So CD4 releases interleukin 2 to cause the maturation of cytotoxic T cells, which are CD8. They release interleukin 4 to grow B cells, right, into plasma cells. So 4 sends 4 to grow B. So CD4 sends interleukin 4 to grow B. And CD4 sends interleukin 2 to grow 8, which is cytotoxic. All right. And then they release interferon gamma, and as we know, interferon gamma activates macrophages, so that's one thing you should know. And it's involved in the delayed type hypersensitivity. We'll talk about all the types of hypersensitivity in a minute. Okay, so suppressor T cells, because everything has, every single action in the body has a regulator to it, and this is no different. Suppressor T cells, although it says CD8, it could be CD8, but the point of suppressor T cells is to regulate CD4 and CD8, so basically kind of like a feedback mechanism, sort of. And then you go to the CD8 cells, which are the cytotoxic ones. They are activated by interleukin 2, released by CD4 helper T cells. Right, okay. So, cytotoxic T cells, they recognize and attack non-self antigens attached to MHC1 receptors. So here's another thing you should know about. So CD4 they recognize MHC class, they use MHC class 2 receptors, while CD8 use MHC class 1 receptors, right? Okay, so there's that, and they attack them based on it. As we said, the cell-mediated immunity does not require antibodies, and effector cells in cell-mediated immunity are macrophages, cytotoxic T cells, and natural killer cells. These are the cells that attack and kill pathogens. All right. So you have the intradermal skin test. The TB skin test, if anyone has done it, is a type of cell-mediated immunity, type 4 hypersensitivity. We will also be talking about it. And infections associated with defects in cell-mediated immunity. So here's the thing, right? You have B cells. B cells attack bacteria, right? And that's it. They don't attack viruses, and they do not attack, except for IgE, I believe, any sort of other pathogen, parasites and stuff, right? So it's cell-mediated immunity. T cells, more specifically, attack viruses and other intercellular pathogens like tuberculosis, for example. So there's that, okay? You should know it. In terms of B cells, they come from the bone marrow. That's because it's humoral. So B is for bone marrow, T is for thymus. I don't know if that's exactly the naming behind it, but that's basically how you kind of memorize it. And the most important thing you need to know is that 10% of them become memory cells, sure, which can be reactivated. You don't have to really know that. B cells, basically, right? They produce antibodies. What are those antibodies? So there's IgG, IgM, IgA, IgE, IgD, and all that stuff. What you need to know specifically in this case, at least, to begin with, is IgM. Whenever you see a high IgM, it's usually an acute disease, an acute infection, right? So when you're testing for antibodies for hepatitis A, for hepatitis B, for example, if you see IgM and you don't see IgG, that means this is a new infection, like a recent active infection. IgG is usually, okay, the body's like, yeah, I got this. Like he's like the OG, right? He remembers it already. And if it's usually high, it's either a reinfection or that it's already there, right? But it's usually the case of a reinfection. So this is not the first time the body has seen this disease or foreign pathogen. All right, so you have MHC classes, as we talked about. So there's MHC class 1, MHC class 2. 1 is ABC, 2 is DR, DP, and DQ. You don't really have to know this in details. Just know that MHC class 1 is CD8 and MHC class 2 is CD4, right? And when you talk about CD8, that's a cytotoxic. When you talk about CD4, that's a T helper. And MHC class 1 is present on all nucleated cells, right? And it's the target for cytotoxic T cells. So if a cell does not have MHC class 1, that's when cytotoxic T cells are like, hey man, what are you doing? Like, who are you? Like, get out of here. You know what I'm saying? All right, and MHC class 2 is the antigen present on antigen presenting cells. And these are the antigen presenting cells usually go to antigen presenting cells basically engulf sort of the the pathogen, and then they present the pathogens like a part of it, let's just say, on sorry about that. Yeah, they present part of the pathogen on their cell surface. So, and what's the point of it? They go to B cells and they're like, hey man, create antibodies for this pathogen, right? And then they go to helper T cells and they're like, hey man, activate the system, all right? Let's get the immunity going, you know? So antigen presenting cells are like the snitches. They take the criminals and then they snitch on them to the humoral and the cell-mediated immunity. Okay, and antigen-presenting cells, as we said, activate T cells and B cells to release antibodies. And then you have viral infections and bacterial infections. As we said, viral is T cells, bacterial is B cells. Natural killer cells. These are, I love the name, natural killer cells, right? So they're not restricted by MHC. They don't need MHC to grow or not. They don't need, like, the cytotoxic, they need to see the MHC to be like, hey man, like, you are off. Let me attack you. Natural killer cells don't need that. They can recognize cells that lack self-MHC. I mentioned before that the CD8 cytotoxic T cells are like, oh, you don't have it, let me attack you. That's wrong. That's not it. It's natural killer cells. CD8 require they recognize foreign MHC, but if there's no MHC, you need the natural killer cells because these are the ones that attack the ones with no self-MHC. And part of the body's natural immune surveillance for cancer. And that's why it's very important to have natural killer cells, because they're usually the ones, or part of the team that attacks cancerous or cells that mutate inside the body. And KMS. Alright, so the second page of Absite usually has like just the drawings of it and all that stuff, and the antigen presenting and how like proteasomes present and all that stuff. Not really important. What you should know in terms of antibodies, as we talked about, there's IgM, which is the initial, and it's the largest antibody. It's usually most commonly found in the spleen. You have IgG, which is the most abundant antibody overall. IgM is the largest. IgG is the most abundant. And IgG is responsible for secondary infections, right? And IgG usually can cross the placenta and provide protection in newborn period. So that's why a lot of kids with certain diseases, like, for example, X-gamma globulinemia, Bruton's, I think it's Bruton's A-gamma globulinemia, which basically means they don't produce any antibodies. For the first, I think 4, 5, 6 months even, they're fine. They're sort of fine because they have the antibodies, the IgGs, from the mother. So they don't need to create their own. But afterwards, when that goes away, that's when they're like, oh, I don't have any antibodies. No bueno. All right. You have IgA. When you think of IgA, just think of like mucosal areas, right? And where do you see any mucosal areas? It's usually either the GI system or the respiratory system, right? And it's especially found in secretions. That's why I think about mucosal. So there's Peyer's patches in the gut. There's breast milk. Oh, breast milk is important, by the way, as well. And it helps it helps. And why did I say mucosal areas? Because these are the areas exposed to the rest of the world, right? So like your GI system and the respiratory usually, and these help these prevent microbial adhesion and adherence and invasion. So they stop it from like sticking to the surface of and entering our body through the mucosa. Okay, and then you have IgD, which is, I don't know, it's a receptor on B cells, whatever. IgE is like allergy, and it's usually for two things, majorly. Whenever you see high IgE, it's either, three things really. There's job syndrome, but never mind that. Focus on allergic reactions and focus on parasitic infections, right? And when you think about allergic reactions, it's type 1 hypersensitivity reactions. We will get there. And the parasitic reactions, the infections are just that, parasites, right? And then you have IgM and IgG are opsonins. Opsonins are basically like things that are on the surface of cells that tag them for the immune system, right? So whenever a cell is tagged with IgG or IgM on its cell membrane or cell surface, the body's gonna think, oh, like, this is how I'm gonna attack you. This is how I'm tagged, whenever you want to tag, I don't know, whatever, right? And then they help fix complements as well, not really that important. All antibodies have 2 antigen binding sites, except IgM has 10 because it has 5 subunits and all that stuff. Never mind that. There's the variable region, the constant region. Again, not very important. When you want to get to the important part, to be completely fair on that page, you look at the basophils and you look at the mast cells. And when you look at the basophils, it starts with a B. Baso, B, baso, B. Blood is also B. So basophils are in blood, and the other one, which is mast cells, are in tissue. And they both are the major source of histamine release, right? And when you think about histamine release, what do you think about? Allergic reaction, right? That's why you take antihistamine for it. Anyways, we'll get to the hypersensitivity in a second. I just want to mention one last thing. The primary lymphoid organs, right, are the liver, the bone, and the thymus. We know the bone and the thymus, but the liver is also very much involved. A secondary lymphoid organ are usually the lymph nodes, and the other one that has a high abundance of IgM is the spleen. Exactly. Yes, sir. All right. Hypersensitivity reactions. These are probably the second most important thing in this chapter for the Absite exam, right? Hypersensitivity reactions, just think of them as 1 to 4. And 1 is just IgE, right? It's allergic reaction. That's all you need to know. IgE receptors on mast cells and basophils, they react with the antigen and they cause the release of histamine from mast cells and basophils, as well as serotonin and bradykinin. But the most important one is histamine. That's why you give an antihistamine. But at the same time, if it's a very strong allergic reaction, it turns into what? Anaphylaxis, exactly. And when you want to, what do you give for anaphylactic shock or anaphylaxis in general? You give epinephrine, right? And that's because there's bronchoconstriction and you want to bronchodilate, and there's also hypotension from vasodilation and you want to vasoconstrict, right? And that's what you want to talk about, like epinephrine and doses and all that stuff. Not really important. We'll get to it. I think there's later in the book. All right. And obviously there's airway management in the case that you might require intubation. So this is all for type 1 hypersensitivity, which is literally sensitivity. Like I'm sensitive to something, right? Allergy, anaphylaxis. Type 2, when you think of type 2, just think about antibody, right? That's it. It's just antibodies. So what are some of the examples of things that are attacked by antibodies or cause a problem by antibodies alone? So there's ABO incompatibility if you give the wrong blood to the patient. There's hyperacute rejection, again, similar to ABO incompatibility, and I think we talked about it previously. Hyperacute rejection. There's myasthenia gravis. Myasthenia gravis is basically antibodies to the acetylcholine receptors on the neuromuscular junction, and they cause there's a whole disease for it. No, it's not a simple thing. And then you get to immune complex deposition, right? Immune complex deposition. So type 1 is sensitivity. Type 2 is antibodies. Type 3 is not antigen or antibodies alone. It's both, right? It's antigen-antibody complex. Like type 1 is kind of like the antigen, right? Type 2 is the antibody. Type 3 is the antigen-antibody complex. Together, they join and they go places and they make a destruction, right? Bigger destruction. They cause serum sickness and they cause SLE. Obviously, they cause other things as well, but these are the most prominent ones. And the type 4 that we wanted to talk about previously from the TB skin test, not the humoral response, the cell-mediated response. So this is not antigen, this is not antibody, this is not antigen-antibody, this is just T cells, right? And this is the cell-mediated immunity, delayed type hypersensitivities, where antigen-presenting cells present the antigen to the helper T cell, and then the helper T cell takes it and activates the macrophages to destroy the antigen. And examples of that is contact dermatitis and TB skin tests. And the nice thing about it, in order to differentiate it from the other ones, is usually ABO incompatibility is pretty like the effects are almost instant, right? Immune complex deposition, that's kind of late. Serum sickness and SLE, it takes time. But if a patient comes that isn't like a contact dermatitis, right? He gets in contact with something that he is like hypersensitive to. If it's an immediate reaction, usually it's a type 1 hypersensitivity. But if it's a delayed reaction, it's usually type 4, because type 4 hypersensitivity takes 2 to 3 days, right? All right, and then you have interleukin-2. We said CD4 release interleukin-2 to activate CD8. So helper T cells release interleukin-2 to activate cytotoxic T cells, right? They convert lymphocytes to something called lymphokine-activated killer cells, which isn't really that important for you to know in specific, but the one thing you should know about them for lymphokine-activated killer cells and tumor-infiltrating lymphocytes, so LAK and TILs, is that they are very important for attacking, for the immune response for tumors in general, right? What else is important for the immune response for tumors in general? We talked about this. Natural killer cells, exactly, right? And tetanus. Okay, so this is like I don't know, I don't like the way they wrote it here, so I'm gonna like simplify it for you guys, right? And the best way to do this is to put it on a table and look at it, but I'm gonna give you the gist of this, right? When do you give? So basically, you have a patient with a wound, right? So the patient can either have taken the tetanus shots, the 3 doses, or not taking the tetanus shots. Whether they took 1 or 2 or none does not matter. As long as it's not 3 or more, it does not matter. They're the same. They're in the same category. So less than 3 or unknown is the same. 3 or more, that's when you're like, okay, now I can, like, that's another category. And then you look at the wound. Is it clean or is it dirty? Let's start with a clean wound because it's simple. In all cases of a clean wound, right, you will not be giving also you can either give a toxoid tetanus toxoid vaccine or tetanus immunoglobulin, right? Immunoglobulin. The only time you give the tetanus immunoglobulin is if it's a dirty wound for a patient who has not taken the full course of the vaccines, or which is the 3. So dirty and not taking the full course, right? Everything else does not take the immunoglobulin. The clean that has not taken the full dose takes tetanus toxoid. And then you have the patient who has taken all the 3 doses, right? They've taken the full course. When do I decide if I give them the vaccine or not? If it's a dirty wound, and they haven't, and the last dose was more than 5 years ago, you give them. And if it's a clean wound and the last dose was more than 10 years ago, you give them. Does that make sense? Right? So if they've taken all the doses, and the wound is dirty, if the last dose was more than 5 years ago, you give them a tetanus toxoid. And if it's a clean wound and they've taken all the doses previously, but the last dose was more than 10 years ago, you give them the tetanus toxoid. If they haven't taken all the doses and it's a dirty wound, you give them the toxoid and the immunoglobulin, and they haven't taken all the doses and it's a clean wound, you only give them the tetanus toxoid. Again, I can go back, I can keep repeating this as much as you want, but the problem with this is that you need to put it right in front of you in order to memorize it. Just a quick, small table, right? And that basically summarizes the immune chapter of the Absite review.